Hello and welcome to your very first APES Edpuzzle video. It is me, Miss Broussard. I've got Fish with me today. Yay, Fish. We're going to name her Dolly. So why in the same hill am I making you do Edpuzzles? Well, that's because we are, our class model is what we call a flipped classroom. There's a lot of research that shows when we have a flipped classroom, there's higher APES scores. What in the world is a flipped classroom? It's where you're doing the lectures at home and we're exploring the concepts that you learned in those lectures in the classroom, right? So most of your note-taking and kind of formative vocabulary assessment is going to be happening at home for this classroom. Again, I'm going to try to keep these videos really short. I know you guys are busy lives, but you learn kind of the basic concepts at home, then we explore those. Why is this beneficial? Well, you are able to self-pace. If you need to take a little bit longer or a little bit shorter on different concepts, you're able to kind of modulate that. We're doing the easy stuff at home. All you have to do is watch a video and answer like very surface level questions about it. It's not going to be that hard. We're able to explore that more intense concepts than in the classroom where you have me, where you have your peers and you're able to kind of work together through that. And it's very easy to catch up because the videos are going to be posted and you'll have a couple days to do that. So what does that mean that you need to do? The Edpuzzles, what you're watching right now, this is an Edpuzzle. So you watch the Edpuzzles, you can take notes on the Edpuzzles. These Edpuzzles are going to go complementary to the concepts that are going on in the textbook chapters. For example, this first one's going to be over chapter 1. And there is a reading guide that goes along with the textbook readings. You fill those out. Not only can you use those reading guides on the quizzes, but you also can turn them in as bonus points, extra credit on your unit exams. And it helps you study. So there's like literally nothing bad about it. It's all good things. We'll talk about this more in class, but this is just kind of your overview of what in the world an Edpuzzle is and why we're doing them in APES. So we're going to start out with chapter 1, as you should. In a class, we're going to be studying the state of our Earth. We've talked about this a little bit. You probably also saw it a little bit when we were doing APES trivia, tragedy of the commons. This is kind of an overview of the class as a whole. We're going to explore this more, throughout the entire year. We'll be talking about the world around us, but also how we as humanity and human beings actually alter these natural systems. So when we talk about ecology and we talk about populations, we're going to be talking about diversity. How do we as humans affect that ecological diversity? Later this year, when we get into agriculture and food production, we'll also be talking about how do we as humans affect all of that around us. How are we affecting the land? How are we affecting the space that we have, depending on our different diets? When we get into climate change, we'll be talking about how we affect the chemistry of the world around us. How do we affect all of the oceans? Yes, we as humans affect the oceans quite a bit. Human populations and resource depletion. Resource depletion should probably be very forefront of your mind if we just did the tragedy at the Commons Lab. A lot of people made their little ponds extinct. So resource depletion is also another way that humans alter systems. This ties into a very key term, which is called sustainability. I invite you, if you would like, you can pause the video real quick and think, what exactly is sustainability? What does that bring to mind? Okay, if you've repaused or unpaused the video, sustainability is living on Earth in a way that allows us to use our resources without depriving future generations of those same resources. So it's a balance. Obviously, we want to have our own economic development and our own economic gain. I know that's a huge part of the American culture, but we also want to think about our future generations, our grandkids, great-grandkids, and we want to make sure that there's still enough resources for them to live a long, happy life as well. How do we live sustainably? We want to make sure that we're using them in a respectful way, right? We're not damaging any resources. When we get into agriculture, and even pretty coming up soon is going to be soil, we'll talk about how are ways that we actually balance our resource use in our soils. Soil can be a tapped resource, right? We can get to the point where we till the land where it's no longer productive, where we strip away all those nutrients, and then that soil is damaged and is not able to produce fruitful crops for us. So we want to make sure that we're being respectful of the land, never over utilizing those resources. When we get into resource usage in terms of energy, we want to make sure that we're using them in a way that doesn't ever exceed the replenishment rate, all resources are replenishable. It just depends on that time scale. So renewable versus non-renewable, there's some differences in how fast those systems and those resources can regenerate and replenish. We want to make sure that our utilization of those don't exceed how fast it takes for them to come back. Otherwise, then we end up in a deficit and we end up losing those resources. All right, so kind of another vocab term, sustainable development. It is exactly what it sounds like. It is development that balances current human well-being. We want to advance. We want to make sure that we're taking care of our people here today, but it balances current human well-being and economic advancement with resource management for the benefit of future generations. So we're sustainably developing, we're still advancing, but we're also thinking ahead of all those future generations and making sure that we have enough for those in the future. That scared me. I don't know if it scared you, but it scared me too. With the Edpuzzles, just because sometimes it can get all boring and stuff. I'll throw in some funny pictures. So this is one of those face swaps, and someone face swapped with a cookie. Oh my gosh. All right. Another big concept that we'll be exploring this upcoming week is ecological footprint. Now, your ecological footprint, in a way, essentially is measuring in hectares, which is an area of land, how many resources that we consume and how much space we need, not only to produce those resources, but also how much space we need to take up and hold in all the byproducts from that resource use, right? So we're thinking about how much space do I need? How much land do I need for energy, for land and habitats? How much do I need for timber, for food, for seafood? And we're looking at not only built up land, but how much forest, farming land, the amount of space that we need in order to develop our resources and produce the energy for us to live. Kind of what that last slide was saying, I mean, this is just kind of more of a formal definition of it. The amount of biologically productive land needed to supply the people with resources and also absorb and recycle waste and pollution produced by such resource use. Our footprint, our ecological footprint, that amount of hectares needed to support and sustain a population, we always want it to be in balance with something known as biocapacity. We'll talk about this more in class, but biocapacity is how much land and resources that are available in an area. So we always want to make sure that our footprint, how much we're consuming, is in a balance with the biocapacity, how much resources the land actually has to offer us. If what we're using exceeds or goes beyond the biocapacity was available, we're going to end up in some bad news bear situations where we have some deficits of our land and energy resources. So ecological footprint is a measure of area in hectares, but I mean, I don't know about you guys, but if I went to a trivia game, I would not know what a hectare is. So a hectare essentially is 10,000 square meters. For those of you guys who play football, soccer, it's just a little bit bigger than a football field. If you run in track and cross country, usually the track, that grassy area, is about 1.1 hectares. So that kind of gives you a visualization of how much it actually is. Blah, I feel like my face is blocking the screen. How much biologically productive space is actually available? Well, if we look about the land around us, right, the whole world, we're taking in forest and woodland, pasture land, arable land for farming, other land, and what we've already developed. You don't need to know these numbers. This is just kind of for your common interest. We have 11.3 billion hectares in the world. That's all of our croplands, our forests, our fisheries. This is not productive land or non-productive land, right? So this is excluding deserts, glaciers, open ocean, where I'm not going to be farming, right? I'm not going to be building up my settlements. I'm not going to be raising my cows. So if I take up the biologically productive land, what I can actually use to produce those resources, divided by how many people are in the world, that's about 1.5 hectares available per capita, which also means per person. That's a very key term. Per capita is per person. So we talked last week about how our world's population has doubled over the past 50 years. This number, how much hectares is actually available per person of arable land, as our population increases, that's going to decrease how much land is actually available as our population increases, right? We're having to divide it between more and more people. This ends up being a problem, especially as in countries like the United States, developed first world countries, our ecological footprint, how much resources we're actually using, is way higher than what other countries are using, maybe third world countries that aren't as developed yet. So we end up having a lot of disparities between different countries around the world. Face is in the way again. We talked about this a little bit earlier, but just really making sure this hits home because this is a pretty key concept. If my biological capacity, so the world's land, what it is actually able to give to us, if the world's biological capacity to replenish those resources and absorb the waste and pollution is exceeded or overtaken by the population's footprint, what we're using, then there's an ecological deficit. So this means if what I'm using is greater than what is available, then we've got a disparity, right? We're using more than actually is available. We're going to see a deterioration of the land. This week, we'll actually explore a real life scenario of what happened when a human population did drastically exceed their biological capacity, and it was not great for them. So we'll talk about that later this week. All right, so this is just kind of an overview. As I was saying earlier, there is a lot of differences around the world on the terms of ecological reserves. So how much are people using ecological footprints versus biocapacities? So our red and orange countries, yeah, yay, America is flaming hot red. Our reds and oranges, these are going to be countries where the ecological footprint is greater than the biocapacity. We are actually in deficits where we're using more resources than our land actually has to give to us. How are we still alive? How is our society not collapsed then if we're using more than we actually have? Well, nowadays we actually have something known as trade. So we're able to trade with other countries, which allows us to continue to develop, even though our ecological footprint is way beyond the biocapacity of our land. Our countries that are in yellow and green, these are areas where their ecological footprint, how much they're using, is actually lower than the land that's available to them. So they have what's called a reserve, or they have excess of resources. We do see a lot of correlations with the developed versus developing countries and their footprint. So the higher the income in an area, typically speaking, the higher the ecological footprint or resource and land usage. So when we have a developing third world country, they don't have maybe as much structures, they may not have as many facilities around them. So they usually are going to have a smaller ecological footprint. They're probably going to have an ecological reserve because their biocapacity is not going to be fully utilized. Whereas in America, we have a lot of sustained structures around us. We tend to be a wealthier country. And so we're going to actually have that correlation where the higher the income, the higher the wealth in the country, the more resources we're utilizing in the area. Why do first world developed countries end up having that larger ecological footprint or resource usage? Well, a lot of it has to do with our diet, our food. When we did Apes Trivia last week, we said that it takes 54 times as much water to produce beef than potatoes. I think it was 1 kilogram. I can't remember exactly. That's a lot more resources used. So because in America, we tend to have a very meat-rich diet. I mean, a lot of us have meat like 2-3 times a day, or at least once a day. That takes a lot more resources to produce than a vegetarian or less meat consuming diet. There we go. Energy. Remember, we also said that the US and China are the top leaders in energy usage, even though the United States does not have one of the top 2 population sizes. So because we have all this infrastructure for energy usage, we're going to have a lot more of an ecological footprint because we're using so much more energy. But we don't have as many structures in place to take up that CO2. So we need a lot more land to actually absorb that byproduct from that energy usage. Finally, it also depends on the biome of the area, right? What's our territories like? So, for example, areas that have a lot more dense vegetation, marshes, swamps, wetlands, peat moss, all those are huge CO2 consumers and fixers, right? They're absorbing this carbon dioxide that's in the atmosphere. They're keeping it down below the surface, which as a whole means that their biocapacity is better. They're better able to absorb and take up that waste product, which again is part of that ecological footprint. In the US, we have a lot of developed land, right? We have lots of structures, buildings, streets, roads, less vegetation in some areas, which means we have less ability to absorb that CO2. Okay, we're almost done, guys, almost done. Just to kind of summarize this, this is kind of an older graph. I mean, it only goes until 2001, but we see in general, the countries that have higher income compared to middle and low income countries end up having a larger ecological footprint. Those ecological footprints, again, is measured in hectares. It's our last slide. Yay! We're going to end today with a joke. How many tickles does it take to make an octopus laugh? Of course, it's 10 tickles. This concludes your very first Apes Edpuzzle. I just wanted to say that you guys are awesome. Hang in there. Let me know if you guys have any questions, and I look forward to seeing you guys in class. Thank you so much.